Hey everyone, welcome to the channel. In today's video, we're diving into one of the most exciting and transformative fields in tech, machine learning. You've probably heard of it, but what exactly is machine learning? How does it work? And why is it so important? We're going to explore the basics, from the core concepts to real-world examples you encounter every day. Whether you're a beginner or looking to sharpen your knowledge, by the end of this video, you'll have a solid grasp of the fundamentals of machine learning. Let's jump right in. What is machine learning? Show examples like spam filters, recommendation engines, and voice assistants. So what exactly is machine learning and why is it different from traditional programming? In traditional programming, a programmer writes explicit instructions for every task. The computer follows these instructions to perform the task exactly as written. But machine learning is different. Instead of being explicitly programmed for every situation, a machine learning model learns from data. Think of it this way. In traditional programming, you provide the rules, and the machine gives you the output. But in machine learning, you provide the data and the desired outcome, and the machine learns the rules itself. Machine learning is used in a wide variety of applications today. For example, when you browse online stores and see product recommendations, that's machine learning. When your phone's voice assistant understands and responds to your commands, that's machine learning. It's all about enabling machines to learn patterns, make predictions, and adapt based on new information. Section 2. Supervised versus unsupervised learning. The biggest difference between supervised and unsupervised machine learning is the type of data used. Supervised learning uses labeled training data, and unsupervised learning does not. More simply, supervised learning models have a baseline understanding of what the correct output values should be. Split screen showing a labeled dataset, e.g., camel and cow images, on one side for supervised learning, and an unlabeled dataset on the other for unsupervised learning. Let's talk about two of the main types of machine learning: supervised and unsupervised learning. These are the foundational approaches used to train machine learning models, and understanding the difference between them is key. In supervised learning, you work with labeled data. This means the dataset you use already has the correct answers provided. For instance, if you want a model to identify images of camel and cow, you would give the model a large number of labeled images, where each image is clearly marked as either camel or cow. The model then learns from these labeled examples and tries to generalize patterns that will allow it to classify new images correctly. Supervised learning is highly effective for tasks like image classification, spam detection, and even predicting stock prices. On the other hand, unsupervised learning deals with unlabeled data. The model doesn't have any specific labels or instructions. Instead, it tries to find patterns on its own. One common unsupervised learning technique is clustering, where the algorithm groups similar data points together. For example, a retail company might use unsupervised learning to group customers based on their purchasing behaviors, identifying natural clusters of high spenders or deal seekers, without knowing ahead of time what those groups will look like. Section 3. Key concepts: algorithms, models, training, and testing. Diagrams illustrating data being fed into an algorithm, building a model, and evaluating the results. Now let's dive deeper into some key concepts that are at the heart of machine learning: algorithms, models, training, and testing. An algorithm in machine learning is a mathematical framework or set of rules used to analyze data and make decisions. Think of algorithms as the blueprint that tells the system how to learn. There are various types of algorithms, like decision trees, neural networks, and support vector machines, each suited for different tasks. A model is the result of running an algorithm on data. After being trained on your data, a model can make predictions. For example, if you trained a model to recognize cats, that model is the entity that makes the final decision. This is a cat, and this is not. Training is the process of teaching the model. You feed a machine learning algorithm with lots of data during training, and the algorithm adjusts its parameters to improve performance. This involves minimizing errors and optimizing for better predictions. A well-trained model is one that can accurately make predictions on new, unseen data. After training comes testing. Here, we evaluate the model's performance by using data it hasn't seen before. This step helps us understand how well the model generalizes to real-world data. Testing helps catch issues like overfitting, which occurs when a model performs well on training data, but fails to generalize to new data. The goal is to create a model that strikes the right balance between accuracy and flexibility. Section 4. Real-world examples of machine learning. Example: autonomous cars driving, a doctor using AI software, a person using a streaming platform. Machine learning isn't just a theoretical concept. It's already shaping the world around us. Let's take a look at some real-world applications where machine learning is making a massive impact. Recommendation systems. Whether you're on Netflix, YouTube, or Spotify, machine learning algorithms are working behind the scenes to recommend content you're likely to enjoy. 1. These platforms analyze your past behavior, such as movies you've watched or songs you've liked, and make personalized suggestions. 1. This helps improve user engagement and satisfaction. 2. Autonomous vehicles. Machine learning is at the core of self-driving cars. 2. Companies like Tesla use machine learning algorithms to process data from sensors and cameras to help cars see the world, recognize objects, and make driving decisions. 2. Every time a self-driving car encounters a new situation, it learns and improves its driving behavior. 3. Healthcare. In medicine, machine learning is revolutionizing diagnosis and treatment. 3. For instance, AI models trained on thousands of medical images can help doctors detect early signs of diseases like cancer. 3. Machine learning algorithms also analyze patient data to predict health risks and recommend personalized treatment plans, making healthcare more efficient and accurate. These examples show that machine learning is far from being a niche technology. It's already affecting industries from entertainment to healthcare and transportation. As this field continues to evolve, we'll see even more innovative applications of machine learning transforming everyday life. Thanks for sticking around. We've just scratched the surface of machine learning, but I hope you now have a better understanding of what it is and how it's being used in the real world. If you found this video helpful, give it a thumbs up, and don't forget to subscribe for more content on tech, AI, and data science. If you have any questions or ideas for future videos, drop them in the comments below. Until next time, keep exploring and stay curious. Thank you for watching my video.